All right. Hope everybody's doing okay today. Don't forget a couple things that, tomorrow we have our quiz. At the end of class today, I'm going to pass back those exit tickets. Your quiz tomorrow is going to look, just like it. It's not multiple choice. You'll be able to use your notes, though. It's just going to have a blank for your answer or your answers on solving the trig equations. And then your test next week on Thursday will also be over trig equations as well. We are going to go ahead and start the next unit. Now, if that's Friday or even Tuesday, that's fine, but we're going to move on to vectors after this. Kind of change things up a little bit. Okay, but we have our first focus activity because we did some happy minutes at the beginning of the grading period. Using the sum and difference identities, so it's actually been a while since we've seen those. Condense each of the following and express as a trig function of a single angle. Okay, so it's been long enough, maybe we need to go ahead and review those. If I were to have sine of alpha minus beta versus sine of alpha plus beta, okay, what was the pattern here? I remember sine wanted to keep something, but they wanted to change something else.
They wanted to keep the sine, but change the sine cosine.
There we go. So when you multiply, we alternate, but we're going to keep the same operation. So we always go in order from alpha, beta, left to right. So this would be, okay, sine of alpha, cosine of beta, minus cosine of alpha, sine of beta. Now, sine of alpha plus beta is going to be exactly the same, except instead of the minus, it's going to have the plus. So it would be sine of alpha, cosine beta, plus cosine alpha, sine beta. And now let's do the same thing for cosine of alpha. Let's do the plus first this time. And then cosine alpha minus beta. Okay. And remember, these were just formulas. Once you had the appropriate fraction, you just plugged it in and you simplified. So cosine, what did he want to do?
It keeps them the same, but it switches it.
Okay, so we want to keep cosine times cosine. We want sine times sine. But this one changes the operation. So this would be cosine alpha, cosine beta, minus, because we started with a plus, sine alpha, sine beta. Okay. And then again, cosine of the difference is going to be the same except for a plus there. So cosine alpha, cosine beta, plus sine alpha, sine beta. So this is kind of coming back to everybody. It's been a while since we've seen them. Okay. And now we've got the tangent ones. Okay, now the good thing about tangent, whether it was a sum or a difference, let me write this one over here, alpha minus beta, it was the only fractional formulas that we had. Okay, so up top, you had the same thing, tangent alpha, tangent beta, you had one tangent of alpha times tangent of beta. Same thing over here if it's a difference. Tangent of alpha, tangent of beta, 1, product of the two. Okay. The only thing that changed between them was the signs. If I was adding, what goes up top? Is it a plus or a minus? Plus. Whatever operation you start with, you keep that same operation above. It's below that you go ahead and take the opposite. Okay. So in the other one where I'm subtracting, I'm going to keep the subtraction and then I'm going to put the addition. Okay. So those were my sum and difference identities. It's been actually quite a while since we talked about those, but I thought why not, focus activity, kind of review it. So let's see here. This one's already been expanded for me. It says using the sum of difference identities, condense each of the following as a single trig function. Okay, now this one here, it goes sine, cosine, cosine, sine. Is that based on sine or cosine's pattern? Okay, what's that, Angel? Sine, yeah, you're alternating the product, so it's got to be sine, and I know that we're adding, right? So this one has to be alpha, this one has to be beta. And all we got to do is just add them up. 97 plus 43. So what is 97 plus 43? Okay. Would you guys agree? 150? Are we sure? There we go. We're so close. There we go. It is 140. Now, if it had been 150, if it had been one that we recognized on the unit circle, we'd go ahead and simplify it. But this one, it just said write it as a single angle. So that's all we're looking for right here. We're not going to evaluate it. Okay. All right. Now, if we look at the next one, cosine 72, cosine 130, plus sine of 72, sine of 130. Well, what's this one? Is it based on sine or cosine? This one's cosine. See, we have the cosines together, we got the sines together. Now, the thing about cosine, when you expanded it, it used the different operation. So this one, I know I'm going to subtract. So we always go in order. So it would be 72 minus 130. Okay. So what would that be? Negative what? 58. So cosine of negative 58 degrees. And here's the thing. Do you guys remember, is cosine an even or an odd function? Is it what, Andrea? It's even. There we go. That means if the angle measures negative, this is exactly the same as just saying cosine of 58 degrees. Okay. If it's even, it's just like that negative disappears. If it was odd, you pull the negative out in front of the trig function. And 58 isn't a value that we recognize on the unit circle, so we're not going to worry about approximating him. Okay, nothing like that. Okay. Let's try number 3. Now, obviously, this one's a what? Tangent. Okay. So let's see here. The only question is it a plus or minus? Minus. Whatever sign is up top, that's the sign that you're using here. Okay, so we always go in order. So it looks like I have 140 minus 60. Okay, so that's going to be tangent of what? 80. There we go. Okay, do you guys remember that? Okay, any questions? Right. Well, number 4. Okay, and I believe we had some happy minutes on these. We did a quiz on this, but it has been a while. Cosecant of alpha equals 13/5, and we're told that alpha is between pi over 2 and pi. Tangent of beta is equal to negative 3/4, and we're told that beta is between 3/2 pi and 2 pi. So let me go ahead and do this. Let me create a little coordinate plane here. Okay. So let's see. Alpha is between pi over 2 and pi. So what quadrant would that put him in? Okay, put him in the second. So let's put this right here. And let's say that that reference angle is alpha. We always connect it to the x-axis. Now, it's telling me a ratio. Cosecant is equal to 13/5. Does anybody remember what is cosecant's ratio? Is it y over r or r over y? R over y. Remember, it's the reciprocal of sine. So this is the radius. This is the y value. So I'm going to say this is 13, and this other one has to be 5. Remember, I'm using the ratio to tell me where to put those values. Okay. Well, how am I going to figure out the base? How did we do it in the past? Pythagorean theorem. Okay. So Pythagorean theorem, I'm going to take the sum of the squares of the two legs. So x squared plus 5 squared equals 13 squared. So x squared plus 5 squared, 25, is equal to 13 squared, 169. Subtract that 25. So x squared is equal to 144. How do I get x out of x squared? Square root it. There we go. So it is 12. Okay. Now there is something I'm missing. Why is it minus? There you go. Because see, this is left of the origin, so that means that the 12 would be negative. There we go. Okay. So good. All right, well, let's see. Now let's move on to beta. It says that beta is between 3 pi over 2 and 2 pi. So what quadrant would that put him in? That'd be fourth quadrant, because here's 3 pi over 2. Here's 2 pi. Okay. So we're going to do the same thing. Let's say that's beta right there. Okay, the reference angle. Now, tangent is negative 3/4. What's tangent's ratio? It's always y over x. So the y value is 3. The x value is 4. Which one should the negative go with? It is the 3. Bless you. Now this, like the previous one, is a Pythagorean triple. We can use the Pythagorean theorem if you want, but would anybody know the hypotenuse? It's a 3, 4, 5. That's exactly right. Just like the other one is a 5, 12, 13. Okay. Does anybody want me to run through Pythagorean theorem to show you that we're going to get 5? No? Okay. All right, so I've got my 2 triangles. They're all set up correctly. Is there any questions about how I found the quadrant, how I found the sides, anything? Okay. Well, now, given this information, it says I want sine of alpha minus beta. Okay, well, let's expand it. In fact, we already have it right here, so we don't have to write it again. I knew it was a good idea to start with alpha minus beta. So all I want is to find each of these right here, one at a time. Now, let's think about this. If cosecant of alpha is equal to 13/5, what would sine of alpha equal? 5/13. Remember, they're reciprocals, so all I did was flip it. Okay. So this first one right here, sine of alpha, I'm going to put 5/13 times. Well, now I want cosine of beta. So that means I'm going to look over in this triangle right here. What ratio is cosine? He was what over what? It's always x over r. So in this triangle, it would be 4 over what? 5. Sorry, that hurts up. 4 over 5. There we go. See, I'm just taking that ratio for the appropriate triangle one at a time. Now I'm going to put the minus. Now I want cosine of alpha. Okay, so because it's alpha, I'm coming back over to this first triangle. Again, I want adjacent over hypotenuse. So what would that be here? (12 over 13). We only missing one thing. There you go, negative 12 over 13. So that takes care of that one. And now the last one, I want sine of beta. So beta, we move over to this triangle here. So sine, we already said, was y over r. So what would that be? Negative 3 over 5. Everybody see how one at a time I took the trig functions, I just plugged in their fraction, the ratio. Is everybody okay with where I got those? Okay. Well, let's see. How would I multiply those two fractions? What is 5/13 times 4/5? over 60 what? 65. There we go. And now you see I've got a negative times a negative, so this minus is going to stay exactly as is. Now, it's true 20/65 can reduce, but I would leave it as is for the time being because we need a common denominator anyway. So the 13 times 5 will once again give me 65. 12 times 3, 36. So what's a 20 minus 36? Negative 16. Negative 16/65. And I don't believe that will reduce, so that should be sine of alpha minus beta. Questions? Anybody not sure where anything came from? Okay. All right, so in a couple weeks, we'll be turning these in. Definitely put them someplace safe. I've got the second one ready. You'll probably get that on Friday. Get another one or two next week. Okay. Good. All right. Well, actually, we are really close to being done with trig equations. We should definitely finish them up this week. Like I said, if we get the opportunity to start vectors this week, fantastic. If not, then it'll be Tuesday. But there's only a couple of problems left that I want to go ahead and show you. Now, you remember yesterday we were looking at trigonometric quadratic equations? Remember how we factor? What was the method we used to factor those? My father drives a red Mercedes convertible, right? Okay. Corvette. There you go. But there's only really two types left I want to show you. One type is using an identity to help simplify an equation. And then the other one is if we are manipulating x at all. Okay, so we really don't have a whole lot. We'll probably go ahead and spend the majority of our time today looking at the identities. I have a couple of those. So why don't we go ahead and do this? I'm going to go ahead and get everything to the same side. So I'm going to subtract 2. We are on example 9 of that packet that we've been looking at. Okay. The one that I gave extra copies out for yesterday. We're on example 9. And I'm also going to go ahead and subtract the cosine at the same time. So what I'm going to have is 2 sine squared of x minus cosine of x minus 2 is equal to 0. Okay. Now, it's true, it's a quadratic. Okay, we have the 3 terms, but how is this one different from the ones we were looking at yesterday? There you go. The 2 trig functions are not the same. So this is where you're probably going to want to use an identity to go ahead and replace or substitute part of it so that you can get it. Now, every time you see a sine squared or a cosine squared, was there some kind of rule that just popped up? What's a real famous identity that helped me out in a lot of cases? The Pythagorean one. Which one am I talking about? Okay. We know that sine squared of x, what's it, plus or minus? Plus. No, you're right. Okay. And what did it equal? It equaled 1. So you'll notice right here, I have sine squared. Could I go ahead and rewrite that trig function, okay, excuse me, the identity in terms of sine squared? Could I solve it for sine squared of x? What if I wanted this guy right here to be sine squared equals? How would I get rid of the cosine squared? Subtract the what? Subtract the cosine squared, right? Okay. When those cancel, sine squared of x equals 1 minus cosine squared of x. Well, you see how sine squared equals this? You remember when we were looking at the identities? It's been a while, but the same idea applies. If you have a trig quadratic like this and they're different functions, use an identity. Okay, so I'm going to take this sine squared right here and I'm going to replace it with the 1 minus cosine squared. So I've got 2 times 1 minus cosine squared. And then I've still got the minus cosine of x minus 2 equals 0. Now I'm going to go ahead and do just a little bit of algebra here. How do you think I'm going to drop the parentheses? Yeah, just distribute. Okay, so 2 times 1, that gives me 2. 2 times negative cosine squared minus 2 cosine squared minus cosine of x minus 2 is equal to 0. And actually, you're right. The 2's do cancel. 2 minus 2. Now, even if it hadn't, if it had left me a quadratic, well, then we would have factored it like we did yesterday. But the fact that these 2 guys drop off, I don't have a trinomial anymore, so I'm not going to use the my father method. Do you guys remember what did we do when we had a binomial, 2 terms that had something in common? We factored out. Okay. Do you guys remember us doing that? Okay. All right. So what we have here, let me go ahead and write this out. Negative 2 cosine squared of x minus cosine of x equals 0. But you see, by using that identity, we were able to take 2 different trig functions, and now they're all the same trig function. It's going to make it a lot easier to work with. Okay. Well, what do both terms share? They both share cosine. So let me pull out a cosine. Now, remember, because the first term is negative, we want to pull that negative out with it. So I'm going to pull out a negative cosine of x times. Now, what I would have here is 2 cosine of x. Because think, what's negative cosine times 2 cosine? Negative 2 cosine squared. Okay. Now, because I pulled out the negative, this would be a plus 1. So negative cosine times 1 would be minus cosine. And then this equals 0. Okay. And now, what do I do from here? Is there a particular property that we've been using? Starts with a Z?
Zero product.
The zero product property. That is absolutely right. So what does that mean? I'm going to take each of these 2 parts and do what? Set them equal to 0. So if negative cosine of x is equal to 0, I'm going to get some answers out of him. 2 cosine of x plus 1 equals 0. Hopefully I'm going to get some answers out of him. But here's the thing. Like, negative cosine of x equals 0, let's just multiply through by negative. Okay, so that's going to make it positive, but what's a negative times 0? Still 0. Okay, so that one really doesn't change. Okay. The other one, what would cosine of x equal if I subtracted 1 and divided by 2? Negative 1/2. There you go. So the only difference on this problem was, in order to get to this point, I just had to use substitution. I used a previous identity. So there's a lot of strategies you can use. Just isolate the trig function. You can use factoring, algebra techniques, the identities. So now, how would I solve cosine of x equals 0? What would I do? Okay, so I've got a unit circle right here. So Antonio, what do you mean?
Wherever x equals 0 to
Okay. Now, cosine is the x value, so where am I looking?
square root of 2, that's pi over 2.
Okay, here's an x value that's 0.
Pi over 2.
There you go. So I've already got 2 answers right there, just like we've been doing. Pi over 2 and 3 pi over 2. So x equals pi over 2, 3 pi over 2. All right, now let's solve the other one, but this time I'm looking for where cosine the x equals what? Negative 1/2. So I'm going to come on over here. Where do I have a negative 1/2 for x? Okay, I heard 4 pi over 3. There's a negative 1/2 x. And then 2 pi over 3. There we go. Now hold on a second. Here's another negative 1/2 right there. Why wouldn't that count? That's the y value. Remember, we're looking for cosine, not sine. Okay, so I'm also going to add 2 pi over 3 and 4 pi over 3. There you go. Those would be my solutions. Every one of those would make the original statement true if I were to plug in. Okay. And this one is, kind of unique. We're not going to say that every one of the problems, if you were to use substitution, is going to work out like this. Okay. Look at this example that I have right next to it. 2 sine of theta equals cosecant of theta. We're still going to use an identity to help me out. Okay, but it's not going to be near as long a process as the previous one did. Okay, so let me give myself some room here. There we go. Now, what identity do you think I could possibly be referring to if I wanted to go ahead and make both of these the same trig function? Starts with an R. Reciprocal. Okay. In fact, what is the reciprocal of sine? Well, not cosine. It is cosecant. So you guys remember 2 sine of theta isn't cosecant, just 1 over sine of theta. Okay. Again, you see how I was able to get it in the same trig function? So what I would go ahead and do now, just multiply both sides by sine of theta. Okay. So what's sine of theta times 2 sine theta? Okay, so that would be 2 what? 2 sine squared of theta is equal to, well, what are those signs going to do? They're going to cancel, so that just equals 1. And see, now you've got just a basic equation that we've been looking at since before spring break. Everybody okay with how I did that? Okay. Well, now what? Divide by 2. So sine squared of theta is equal to 1/2. I want sine, so for sine squared, I'll take the square root. Now, here's the thing. We know that sine of theta has got to be the square root of 1 over 2. Now, there's something I'm missing, plus or minus. Now, we've actually seen this a lot using trigonometry in here. We just have to simplify it. Does anybody actually know what the square root of 1/2 would become? And if not, that's okay. Let's work through it. When you take the square root of a fraction, that means you can take the square root of the numerator and the square root of the denominator, right? So what's the square root of 1? 1 over the square root of 2. But we don't like to leave the radical in the denominator. What do we call the process of removing it? So what would I multiply by? So what would that become? There you go. And see, that is something we recognize on the unit circle. Okay. So sine of theta is actually plus or minus the square root of 2 over 2. Now, how many of the quadrants am I going to be looking at for my answers? Would it just be 2? Would it be all 4? What are we looking at? Why all 4? Because I want both positive and negative. As long as I can find a y value that is square root of 2 over 2, doesn't matter if it's positive or negative. Okay, so let's go on over here to the unit circle. So my answer. Where in quadrant 1 do I have a y value square root of 2 over 2? There you go. Pi over 4. So that's my first answer. Quadrant 2. There you go. There's another y value. So that's 3 pi over 4. What about quadrant 3? There we go. 5 pi over 4. And I'm not going to have enough room, so I'll go ahead and put a comma right there. And what about the fourth quadrant? There we go. Again, positive or negative, it does not matter. There we go. Okay. How we doing? Any questions? Okay. Well, let me go ahead and show you this then. This is the last type of problem I want to go ahead and show you. It's examples 12 and 13. Now, it says solve on the interval. It says between 0 and 360. But that's the same as 0 and what? Remember, 360 is equivalent to 2 pi. There you go. So it's still the same interval, right? But what's different about this equation? The trig function is already isolated. I don't have to do anything fancy. But there's something different than any other trig equation we've solved to this point. There you go. These equations, they're manipulating the x or theta in some way. Now, here's the thing. Okay, you're still going to solve these problems exactly the same way. All right. You're only going to bring in the 2 at the very last step. Right, Angel? Right. Okay. So here's the thing, though. We need to know exactly where on the unit circle I'm going to be looking. We want to go ahead and do this between 0 and 360, right? Okay. So I'm going to go ahead and say 0 less than or equal to x, and that should be less than 360. Okay. That shouldn't have a equality right there. But what I want to go ahead and do is make this a 2x. So think about it. If I go ahead and put a 2 right here, what am I going to have to do to the ends? I'm going to have to multiply them by 2 as well. Well, what's 2 times 0? 0. What's 2 times 360? Basically, what's 2 full revolutions in degrees? 720. So because this one is being changed, I can actually look in 2 revolutions to get my answers. Okay. So here's the thing. Let's solve it like normal. Okay. All I'm looking for is where tangent is going to be the square root of 3. What's tangent? What's his ratio? Here's the problem. Tangent of 2x is equal to the square root of 3. His ratio is what? Y over x. So I'm looking for all the ordered pairs where I can take the y divided by the x and get the square root of 3. Now, will I be pulling this out of the 4 quadrants like the previous problem? No, why not? Because what's not in front of the square root? It's not plus minus. So I'm only going to be looking at what 2 quadrants? Where is tangent positive? 1. So these are possibilities. And 3, because what's a negative divided by a negative? There you go. So none of these are going to give me my answers. Okay? But looking at these 3 here, which ordered pair, is it pi over 3, pi over 4, or pi over 6, that I can go ahead, take y divided by x and get square root of 3? Well, it's definitely not which one? Yeah, because what's anything divided by itself? 1. So that's not square root of 3. So it has to be either pi over 3 or pi over 6. What do you think it is? And if you're not sure, okay, choose one. Let's go ahead and do a ratio. So pi over 6. So let's take this y value 1/2, and let's divide it by the square root of 3 over 2. Well, what happens when we divide by a fraction? Okay, so this would be 1/2 times 2 over the square root of 3. Those 2's cancel, but is 1 over the square root of 3 going to give me square root of 3? So it has to be the other one. It has to be this guy right here. Now remember, you can go ahead and follow this line directly across to the other quadrant. What's the other location where that should happen? Okay, now here's the thing. Okay. Normally at this point, we would just go ahead and say x is equal to pi over 3, and we'd go ahead and say x equals 4 pi over 3, right? Okay, but it's not just x. What is it? It's 2x. Okay. So here's what we're going to go ahead and do. How would I solve this for x? Yeah, and just because of the way I wrote it, let me go ahead and multiply through by 1/2. So I would get x equals what? What's pi over 3 times 1/2? Pi over 6. For the other one, multiply through. Okay, so 4 pi over 3 times 1/2, that would be 4 pi over 6, so that's going to be 2 pi over 3. Okay. Now, are those going to be my only 2 answers? Why not? Remember, what was the very first thing we looked at on this problem? Okay. We wanted to go ahead and solve this between 0 and 360, but I had to place that 2 in there. So what did it do to my interval? It doubled it. So what I'm going to do here is I'm going to use the idea of coterminal angles. Okay. So this guy right here, oh, what am I talking about? Pi over 6 is what we got as a first answer, right? Because we divided through by the 2. So now, if that's an answer, then going all the way back around would give me a second answer. We also got 2 pi over 3, which is right here. Okay. So one answer came from there. Where do you think I'm going to get another answer? We go all the way around to there. Okay. So basically, what do I want to do to pi over 6 and 2 pi over 3? Remember, if we're going coterminal, what am I actually adding to them? 2 pi. Okay. So what is pi over 6 plus 2 pi? What's the common denominator? 6. So this would be pi over 6 plus, I'm giving you the answer, 12 pi over 6. And what's that? So we also know 13 pi over 6. Okay. So can anybody help me out with the other one? What's 2 pi over 3 plus 2 pi? And maybe if we write it out, that would be a little easier. So here's 2 pi over 3 plus 2 pi. Common denominator would be 3. So 2 pi over 3 plus, what's that? 6 pi over 3. So that would be 8 pi over 3. There you go. And depending on what is happening to x, it could increase your interval or it could shrink your interval even smaller. Okay. Like on the next one, okay, by doubling x, see it doubled the interval? Okay. Look at this next problem right here. Now I'm going to solve sine of x divided by 3 equals 1/2. Do you think it's going to take this interval and increase it or decrease it? It's going to decrease it because we're going to need to divide that by 3. But we'll take a look at that tomorrow. Okay. How we doing? Now, I'll tell you, on the quiz tomorrow, I did not put any of these problems where x is being manipulated. They're just our standard problems, just like the exit ticket. But I did go ahead and put a few of those on the test next week. Okay. And there are a few on the homework. Okay. So I'll go ahead and give you the homework tomorrow. And then we should have some time on Friday to go ahead and work it, maybe some together, and then we'll go from there. Okay. Cool.